Hey, Chris here from ThatTutorGuy. This video is going to cover the solutions to a practice test that we have at this page. So I've got two practice Accuplacers. This particular video is just the solutions worked out and explained, the topics explained, for section 1 arithmetic of the first practice test. The rest of the solution videos, as well as total solutions for a second practice test, can be found at this page. All that's totally free resource. All you need to do is give us your email address so that you can log in and track your progress. Before we get into the solutions, I just want to mention that there's also more in-depth prep for the Accuplacer on the website at this page. We'll need a membership for the deeper stuff, but there's several hours of great content for free at thattutorguy.com/Accuplacer. No one does as well in the Accuplacer as they hope they will, unless they prepare a lot and practice a lot. And every semester that you add to your college career significantly increases the chances that you will not complete the program or the transfer or whatever you're trying to do in college. So really take the Accuplacer super seriously. And then once you get into the class, use thattutorguy.com or other tutoring resources to do well in that class. This is an incredibly important number. And just before we get into the solutions, I just want to emphasize this. 75% of college math students either fail or bail each semester. So if you sit down in college algebra and there's 100 people in the room, only 25 are going to get credit. Don't be one of the 75% that has to go to school an extra semester or whatever. Get the help you need. ThatTutorGuy.com is an awesome resource, obviously, I think, but go to Math Lab, whatever, visit with a professor, because it's incredibly important that you pass each semester to get into. And of course, you want to do well in the Accuplacer to get into a good course to begin with, because if you don't do well in the Accuplacer, that's an extra semester or two of retakes. If you don't believe me, watch the video at the top of that Accuplacer page on the site, because, oh my goodness, I can tell you stories about people who kind of take the Accuplacer not that seriously and then get hammered by it. So while these solution videos are totally free, if you do want to go more in depth on the Accuplacer page, if you look down below the video and down the practice tests, we've got this big table, and this is just part of it, but this includes all the topics that are covered by the test. So on the left here, we got the list of stuff with kind of like mathy sounding terms, the way they're presented by the College Board and their list of topics. And then on the right here, all these orange things are the videos on the site. So each one of these links will take you to a video about that topic. So if you want to prep for the Accuplacer more in depth, as I completely hope you will, because it's a serious thing, this is the way to get to more videos that cover each of these topics in depth. And then also throughout this video, I'll be mentioning like the terms or the things, the names of topics, so you can search for those topics either on my site, which will take a membership, or YouTube or whatever. All right, let's get to it. Now it's worth noting, you're probably not gonna have a calculator on the arithmetic section. If you look at the Accuplacer, it's sort of a little sketchy, like just read their website and like, do they allow you to take a calculator in? No. Will they present one on the screen next to the problem, like in this area? Well, sometimes they will, and most of the time they won't. If it's something really simple like this, they want you to be able to figure it out on your own, so there will not be a calculator. So all these problems, I'm gonna work without a calculator. If you ever do get to use a calculator, it's gonna be different versions. Sometimes they'll give you an online 4-button calculator, which is just something stupid like this with no sine or cosine. You're lucky to have a square root button. They want you to figure this stuff out and be able to estimate, so. All right, so 12/50ths, what do we do? Well, first of all, you want to look at a fraction. Do you know, you can probably guess approximately that this is sort of in the neighborhood of 1/4. Like, oh yeah, we could pull a 2 out for sure, so make that 6, make that 25. That's pretty good. Or we could have doubled it to be 24 out of 100, but the point is that 0.24 is the closest equivalent. So 6/25ths, you know that 6 goes into 24 4 times, so it's around 1/4. So 0.24 is the answer. All right, this is a basic percentage problem. The way percents work is that, as you probably are aware, you just you convert the percentage to a decimal by moving the decimal over 2 spots. So 20% is 20 out of 100. So 20% is the same thing as 0.20. So if you want to you just multiply the total number of balls thrown, 45 balls thrown, 20% of that would be 0.20 times that. So 0.20 times 45. And you can probably do that in your head, but 0.2 times 45 is 9. And if they gave you a 4-button calculator on that one, that'd be easier, obviously. But all right, dividing fractions. This is fun. You probably, hopefully recall that to divide fractions, you invert and multiply. So really it's multiplying fractions, just gotta flip them. So this is really the same thing as 5/10 times 4/3. Now, if you don't remember how to multiply fractions, the one way to, the thing you're basically doing is multiplying the top across each other. So the numerators, 5 times 4 is 20, and then 10 times 3 is 30. And at this point, we can reduce by seeing that 10 goes into both, and that gives us 2/3. If you're confused about anything I just did, that is called multiplying fractions. And also, it's if you're a lot of people would look at this problem and say, oh, shouldn't we cross cancel? Because, hey, 2 goes into this, and 2 goes into this. And yeah, that is one way to do it. And we would have gotten down to 6/15, then had to reduce further anyways. This is called cross canceling. There's something called cross multiplying, which is different. And I just want to mention that to you guys real quick. If you had something like this, like x over 3 equals 6 over 9, then cross multiplying is where you take x times 9, so you get 9x, and then 3 times 6 is 18. That's cross multiplying, and there's different rules and stuff. You would never want to, if you look at this 3 and a 6, you could be like, oh, 1, 2. That does not work. So just when it comes to canceling and cross multiplying, if you're not super sure what you're doing, as long as you're working with fractions, you might as well just multiply it out and then simplify later. So that's why I just went straight across. 5 times 4 is 20, 10 times 3 is 30, and just reduced at that point. Because if you're a little bit confused about cross canceling versus cross multiplying, there's plenty of videos on my site. One of them is called cross canceling versus cross multiplying, because it's such a common confusion. But all right, moving on. All right, we got the measure of 2 angles. What is the measure of the third angle? This involves something called the 180-degree rule, or the 180 rule of triangles. And basically it says that if you have a triangle, the 3 angles have to add up to 180 degrees, 180. And then a related rule is the rule for quadrilaterals, which is if you have something like a parallelogram, they have to add up to 360. And the justification for that is that, hey, look at that, it's 2 triangles. So if this angle and this angle and this angle add up to 180, then this and this and this add up to 180, you can kind of see how that ends up making all the angles of the quadrilateral. So any quadrilateral, any shape, parallelogram or otherwise, have to add up to 360. Anyway, with that little reminder, we can now easily work this problem. 75 plus 15 is 90. So what's 180 minus 90? Well, 90. So the leftover is 90 degrees D. This is a really common type of problem. Shows up in the SAT as well. All right, this topic would be considered improper fractions and mixed numbers. There's a whole chapter about this on the website. But the moral of the story is that you generally want to convert everything into improper fractions and then subtract. So I will work through it that way. Looking at this one really quickly though, well, there's probably 2 good, I was just saying we could estimate. One way to do that would be to convert to decimals. So if you wanted to estimate this and kind of do it in your head, you'd probably say, oh, 3 3/4, that's like 3.75. And 2.5 is 2.5. So we can subtract these and get 0.25, and 3 minus 2 is 1. So 1 1/4 we already know is the right answer. Just to remind you guys how fractions work, I'm gonna work through the right way of doing it as a fraction, because time's not limited on the Accuplacer. So each problem, if you can figure out any way to do it, you should do it that way. 3 3/4. So the way you convert a mixed number to a fraction is you multiply the big number times the denominator, so that's 12. So the 3 represents 12/4, plus we got an additional 3/4. So that's 15/4 minus 2.5. So 2 times 2 is 4. So the 2 is 4/2, plus another half is 5/2. Again, if you're not sure what I'm doing here, got plenty of information on the site about mixed numbers. So now we're kind of good to go, except we got halves and fourths. So we got to convert this 5/2 into fourths. So we'll just multiply top and bottom by 2 to get it up to 4. So really this is the same thing as 15/4 minus 5 times 2 is 10, and 4 downstairs. So that leaves us with 15 minus 10/4 is 5/4. which if you convert to a mixed number is 1 1/4. All right, hopefully that's a good reminder for you. Mixed numbers are annoying, but they are pretty early in your math career. All right, solve for x. Ooh, look, we get to cross multiply. So on this one, that's funny. And the problem I made up out of my head a minute ago was the one so what we do not want to do here, and this is why I want to emphasize, do not get confused between cross-canceling and cross-multiplying. Definitely watch that video. If we did this, we'd be totally hosed. We get the answer equals like 9x equals 2, and we get an answer like a small fraction. The way this is supposed to work is you'd multiply x times 9, so you got 9x. So it's cross because you're like, it looks like a cross you're making there. So 9x equals 6 times 3 is 18, and therefore x equals 2. Really straightforward if you remember to cross multiply and don't cross cancel. If you're someone who's still confused about cross canceling versus cross multiplying, or maybe you remember that that was always a problem for you in high school, then I would recommend that you just never cross cancel. You only cross multiply. So never get cute and start doing this, you know, just always only cross. If there's an equal sign in the middle, that's what allows you to cross multiply. If there's no equal sign, if it's just two fractions multiplied together, then you can do the canceling, but anyway. All right, so when you look at a problem like this, it looks really simple, right? It looks like something you could just type in your calculator very easily. If you see something like this, with just trivial addition, subtraction, multiplication, that's probably a PEMDAS problem. And most of you probably recognize that as soon as you see it, but what it is the order of operations. And basically what that means is when you see a math equation, you're supposed to do parentheses first, then do exponents, then do multiplication and division, and then do addition and subtraction. So if we got plenty of, if you just search PEMDAS on the site, or it'll be linked in the table at the bottom of the Accuplacer page, but we've got plenty of videos explaining what this is and how to do it. Right now I'll just execute it, which is you do parentheses first. So when you look at all these different operations just being like stuff like addition and subtraction and multiplication, we do parentheses first. So you just scan the problem, you look for parentheses, and oh, here's a set of parentheses, and there's a problem inside of it, 2 plus 5. So what this says is whatever's in the parentheses, do it first. So the first thing we're going to do is a 2 plus 5, and that's going to be a 7. All right, there's no more parentheses, so that's done. Now we'll go to exponents. There aren't any exponents in this problem, so we're done with that step. Now multiplication and division happen at the same time, read from left to right, but I don't think it matters whether you read from left to right or whatever. Point is, we've got one division problem here, and that is 56 divided by what is now 7. So 56 divided by 7 is 8. So I'll cross that out, and I just got an 8. So all this junk, this 56 divided by 2 plus 5, that's all now been whittled down to an 8. And now we're done with multiplication and division, and all I've got is addition and subtraction to do. And of course, 72 plus 8 is 80. Now this problem could be really tricky. If they just showed it to you like this, it might occur to you to use PEMDAS. But what they might do to burn you is give you a 4-button calculator like this little guy. Now, if you've been in math in the last 20 years, you know that everyone uses graphing calculators for everything. And you can type in your problem, right? On the big square screen, you type in this exact problem, parentheses and everything, and it just does it for you, right? That calculator knows order of operations. But these little guys and the little 4-button calculator they might give you on this test if they want to mess you up on this problem does not know it. So if I just start typing it, I'm like, oh, 72 plus 56. The second I hit the divided by sign, it's going to do 72 plus 56 and get 100 and whatever. So the way the calculator would do it is like, oh, 72 plus 56. Let's see if this thing works. I can do it right now. So I hit 72 plus 56. Now I hit divided by, right? But as soon as I hit divided, it says 128. So its version of the problem is it's gotten 72 plus 56. It got 128 for that. And now this, because after I hit the divided sign, so now I'm going to type in 2, right? So I'll type in 2. And then as soon as I go to press the plus to get to plus 5, it gives me 64. So what it did was the second I hit this plus sign, it divided everything by 2. So it divided 128 by 2, and now it's saying 64 on the screen. And then 64, it's going to add the 5 to it, and we get a total of 69. Oh, and look, there's the trap answer. So if you just read this from left to right, don't know about PEMDAS, that's what you'll get. So you just want to be really careful to, whenever you see a little list of things like this, they're just trying to burn you. And if they give you a calculator, they're just doing that much more to try and burn you. All right. Oh, look at this. Another order of operations situation. So same story. We got to go the multiplication first. So we would do parentheses, but there aren't any. We would do multiplication, or we would do exponents, but there aren't any. So we'll do multiplication. 3.5 times 2 is 7. And then add this chunk together, and we get B. Now, as far as adding decimals, on a question like this, they probably would not give you a calculator. So you do 8.45, 1.85, and 7.00. So we got 0, 13, 9, 10, 17. So that's how you add decimals, just stack them up. Most people know how to do that. But once again, we are in a PEMDAS situation. PEMDAS always applies, even if it doesn't look like a PEMDAS problem, it is. All right, this one's pretty straightforward, but once again, it's PEMDAS. I know I seem like we've beaten this up, but this one actually has exponents, right? This little 4-button calculator does not. But if they really wanted to mess with you, they would give you one that did. Anyway, so what you want to be careful to realize is, oh, we do exponents before we do addition and stuff. So we need to figure out what the 4 squared and the 3 cubed are, then add them together. All these trap answers, like these giant ones, the way you get those is if you just typed from left to right and you're like, oh, 4 squared is 16, plus 3 is 19. 19 cubed is a massive number. So the way we're going to get this is we'll be like, oh, 4 squared is 16, because order of operations says do the exponents first. 3 cubed is 27. They're still added together. 16 plus 27 is 43. Intro to exponents is the topic name for this in the Accuplacer table on the Accuplacer page of my site. All right, so we got 4 tests. What is the average? So this just involves, finding the mean. That's like the term, the arithmetic mean, spelled like arithmetic. Anyways, so all we're gonna do is just add the average. The formula you wanna know is just the average of some numbers equals the total. So just add those up, divided by the number of items. And most people are pretty familiar with this, especially when calculating their math grades. So 19 plus 20 plus 41 plus 4 divided by 4. 19 plus 20 plus 41 plus 4. And then there's 4 tests, right? Now this is a very simple average problem. We'll see in a minute that they can get a little bit juicier. So 19 plus 41 is 60, 80, 84 over 4 is 21. 10 21ths. So a really weird fraction. Obviously, they will not give you a calculator on this problem. If they did, you would just say, oh, 10 divided by 21. But I think they're going to want you to estimate on this one, which is, you look at these at the answers, and they're all pretty different, right? So if you can even ballpark it. So what is 10 21ths, approximately? Well, it's around a half, right? If this had been 20, then it would just be 0.5. So is this answer going to be a little bit more than or a little bit less than 0.5? A little bit less, right? Because 10 divided by 21, it makes the numerator like smaller than half of the denominator. So it's just under half, so we got choice A. This one looks really similar, but that 0.04 means that would have been like 1 over 21, not 10 over 21. All right, estimating this to the nearest integer. I personally don't think they would give you a problem this juicy without a 4-function calculator, so I would just take 25,691 divided by 271 on the calculator. If that doesn't work out, you're gonna be spending a lot of time dividing. So I don't think they would do that to you. You can do long division. I think that's a basic enough concept. We don't even have it on our site, but anyways, so you could spend all day doing this. What we're gonna do is just divide it on the calculator, which gives you 94.8. And really the only trick to this question is, what is an integer? And integers are just whole numbers. They can be positive or negative or 0, but basically they're saying, hey, take 94.8 and round it to the nearest whole number, which would be 95. Now, if it had been 94.2, that would round down to 94. And then if it was 94.5, which way would it go? 0.5 rounds up. So it would have rounded up to 95 still. All right, that's just a quick primer on rounding decimals, but of course there's more videos about rounding decimals on the site. All right, scientific notation, if that rings any bells. What is 10 to the minus 2? You should know off the top of your head that for scientific notation, which again, we have plenty of videos about that, but 10 to the minus 2 is 0.01. So what's 54.7 times 0.01? One way to do it is actually work out that problem. So if you had a 4-button calculator, you could do the problem. You could do it by hand, 54.7 times 0.01. Work it that way. But the other thing with the scientific notation, the real trick is to say, oh, times 10 to the minus 2, just sort of ignore the 10, whatever. See that minus 2? That means you want to move the decimal 2 places to the left. So negative meaning left, so you just go brr, brr, and bingo, we're at 0.547. So if you're not familiar with scientific notation, you've never seen it before, definitely watch the video on that. 4 out of 5 numbers have the sum of 38. They give you the average and ask you for the last number. So this one's kind of interesting. It uses the same formula. Every time you've ever seen or will see a problem involving averages, it always uses the same formula. Total over n. So that if you added up all the numbers, divide it by the number of numbers, that gives the average. But they can give you, any one of these could be an unknown. So in this case, they've told you there's 5 numbers and they've told you the average. So they've told you the average is 50. And there's a classic SAT trick also. They've told you the sum, but not of all the numbers. So they've told you that 38, some of the numbers add up to 38, like 4 of the numbers add up to 38, but then there's a 5th number that we don't know. But we do know n, there's 5 numbers, right? They told us there's 5 numbers total. So we've got 4 of the numbers. So we could have done like, oh, x plus y plus z plus a plus b sums up to 38, or sums up the total, but then they told us that 4 of them are 38. So we're just solving for that last number. Anyway, so we have an equation now that we can solve for x. So we'll multiply both sides by 5 to get rid of that fraction. And 5 times 50 is 250, equals 38 plus x. Subtract 38 from both sides, and you get x equals 212. Oops. There was another way to work this, like to double check your answer. Speed's not an issue on the Accuplacer. You don't have to be looking for the fast way to do everything. But another way to look at this is if you've had, you've been in math classes before, you've been in classes where you're trying to figure out your grade, like, oh, what do I need on the final in order to, if you know that you have so far like an 85% in the class and you want to get to an A minus, like, oh, what would I have to get? And it's, the math is kind of tricky, but it has to go up. So this one's kind of weird, that the 4 first numbers add up to only 38. So that means the average of the first 4 numbers is like less than 10, and yet the average is going to go up to 50. So how do you move a bunch of low numbers? How do you boost that average all the way to 50? You need a big number, right? So just glancing at these, we could see that 212 is the only one big enough to actually lift the average above 50. None of these other ones will lift. They might lift the average a little, but they're not going to lift the average above 50. So for the average to be 50, at least one of the numbers has to be more than 50. And we have a bunch of small numbers and they want to average up to 50. You need a really big number to make up that gap. All right, Rocco buys 4 3/4 feet of glass. He just uses a little bit. And of course it's a weird fraction. We've got fourths and we've got sixths. So that's a bummer. So the first thing we'll do is we will convert our mixed numbers into improper fractions, then we'll subtract them to see how much we have left. All right, so 4 3/4. The 4 is going to be 16/4 because 4 times 4 is 16 plus 3. So he starts with 19/4, and then he uses 5/6. But of course, we can't subtract fractions where the denominators are different. We can't just do 19 minus 5. We have to do something more clever. So what we're going to do is convert the 4s and the 6 to 12s. So to convert 19/4 to 12ths, get the denominator to 12, we got to multiply 3 down here to get to 12, and therefore we have to multiply the top by 3 as well. So we'll get 57/12 for that left-hand number. And then 6 becomes 12 by multiplying by 2, so we'll have to multiply the top by 2 as well. And now we've got 10/12. So random, we got 47/12, kind of a weird number, but it worked out. So that was converting mixed numbers to fractions, to improper fractions, yet again. 3.45 times 1.2. So this one, they're obviously not going to give you a calculator. It's not a PEMDAS problem. It's just a straight up, figure it out kind of problem. We don't actually have to work it out. Well, just for kicks, I'll do a multiplying by decimals thing because there might be some of you who don't remember how to do this. So when you multiply decimals together, you just do it the same as an old school multiplication problem, except you just put in the decimal later. So 2 times 5 is 10, 2 times 4 is 8, plus that 1 is 9, 2 times 3 is 6, then we put a space holder, then this 1 is 5, 1 times 4 is 4, 1 times 3 is 3. Hopefully I did that right. All right, so then now we've got this number at the bottom, we now account for the decimal. And we've got a total of 1, 2, 3 decimal places if you add up all the decimals in our originals. So we get right here, and there you go. So 4.14 is the answer. Now we could have also done this by estimation. If you look at the answers, they're all kind of different. These two are really close, like 4.14 or 0.414, 0.456 are very similar to each other. But if you're just estimating, you'd be like, oh, well, like 3.5 times 1 would have been 3.5, but this is a little bigger, right? Because it's 1.2, not just 1. So we're looking for a number 4-ish is going to be the answer. If you look at the choices, there's really only one answer that's anywhere close to 4. These guys are way too small. This guy's way too big. So we can kind of get to D pretty quick that way. The Accuplacer is very important, so I wouldn't recommend rushing through or worrying about time. Just work it out, But just when you're double checking yourself later, before you click submit on that problem, think to yourself, let me see if I can estimate this and see if that's about the right answer, So I always like to double check stuff by kind of working it a second way, maybe estimating to see if you're in the ballpark. Because it would be a shame if you had done it correctly this way and then just instead of putting the decimal here, put it here and then gotten the wrong answer. This is not a very good trap answer, but gosh, wouldn't it have been terrible if they had the choice 41.40 as choice E, And then it's like, ooh, if you just get the decimal 1 off, then you get the wrong answer. So that's the kind of stuff they're probably going to do to you on the actual test. So you want to be really careful and use estimating to spot errors after they happen. All right, this one's a very straightforward question. Do you understand square roots? So square root of 4 is 2, square root of 25 is 5, and 2 plus 5 is obviously 7. We'll get into some slightly harder square root stuff in the second section where you actually have to simplify square roots and radicals. If you're not sure about roots, it's Roots and Radicals is the name of the topic on the website. All right, so here we've got a straightforward, well, not straightforward, but it's a lot of fractions and a lot of PEMDAS, so kind of obnoxious. We're going to do just PEMDAS straight up first and then see what happens later. All right, so we got 3/4 first. 2/3 times 1/2. Let's just multiply that out. So you just multiply the numerator. So 2 times 1 is 2. And then 3 times 2 is 6. And then this next set of parentheses, 2/3 minus 1/2. It's like, oops, we got to convert that. So let's convert those both to 1/6 first. So 2/3, got to multiply top and bottom by 2 to get to 6. So 3 times 2. Multiply that one by 2 as well. So we get 4/6 minus, and then 1/2. I have to multiply that top and bottom by 3 in order to get that to 6. So we get minus 3/6. All right, so this ends up being, I'm just crossing that out, nothing. So 4/6 minus 3/6 is 1/6. All right, so once that parenthesis becomes 1/6, we're now down to addition and subtraction because there's no multiplication. So so now we got a bunch of 6. Oh my goodness. So we have to convert everything to 12ths, I guess. So 3/4, multiply top and bottom by 3. So we get 9/12. If you're not sure how I did that, I'm sure I have a video about adding and subtracting fractions. And then 2/6, multiply top and bottom by 2, becomes 4/12. And then subtract 1/6, which is the same thing as 2/12. All right, so now we got all 12ths. We can just add and subtract the numerators. 9 plus 4 is 13, minus 2 is 11/12. And choice B. Unfortunately, there is no shortcut to fractions. All right, somebody named Capono is buying enough wood to make a floor that's 6 by 8. We know the cost of each tile or whatever, or how much it is to make this floor. How much will the floor cost? This is a very straightforward area and cost problem. It happens all the time on the SAT, and it's going to happen here. So basically the trick is just find the area of the rectangle, which they told us is 6 by 8, get its area. Area of a rectangle is just base times height, so that's 48 total square feet, and each square foot costs $1.50. So all we do is we multiply 48 times $1.50. And that gives you $72, which is choice A. Now, if they'd given us a slightly different shape, like a triangle or a circle, and asked the same question, then same trick. We wouldn't use base times height. If it was a triangle, we'd use 1/2 base times height. If it was a circle, we'd use pi r squared. But either way, you'll just find the total area and then multiply by the cost per square foot. All right, got a bag of marbles. Oh my goodness, more fractions, right? So what fraction of the marbles in the bag are mahogany? All right, so we've got a bag of marbles, and the total fraction, it's not really stated here, but obviously it adds up to 1. So if you've got 1/2 a bag of one thing and 1/3 of a bag of another, the way you find what's the leftover, that little sliver that's left over, is you take 1 minus these other fractions. So the amount of mahogany marbles is going to be 1 minus 1/2 minus 1/3. So once again, we've got some fractions here. We got to convert everything to a common denominator. Otherwise it won't work. So 1 becomes 6/6. 1/2, multiply top and bottom by 3 to get 6. So the way I chose 6 as a common denominator is that 2 and 3 both go into 6. So 1/2 is 3/6, and 1/3 is 2/6. So 6 minus 3 minus 2 is 6 minus 5, which is 1. All right, so that's section 1 of the first practice test. We've got 2 more videos covering the rest of practice test 1, and then 3 videos covering practice test 2 on the Accuplacer page. And once you've done well in the Accuplacer, and maybe even get a paid membership so you can really review in depth for the Accuplacer, as I hope I've convinced you to do, because you don't want to like add semesters to your college career if you can possibly avoid it. Because you want to get done. You're working full time. College is tough. But once you prepare for the Accuplacer using that Tutor Guy, I definitely want to encourage you to come back and use it during the school year. So what happens is, and this is, I've tutored enough students, this is what always happens. People start out with the best intentions, and you're like, okay, I'm going to do my homework on time. I remember in high school I used to cram and have to copy homework and stuff, but I'm not going to do that. I'm going to college. I'm going to take it seriously. I'm going to do my homework every day on the day it's assigned so that I can still remember lecture and so that I can be ready for the next lecture. Because if you don't do your homework, you'll be confused, and you'll be more confused in the next lecture. So you're like, everyone starts with the best intentions at the beginning of the semester. But then what happens is you sit down and do your homework, and first of all, it's college, so you're like, holy smokes, this is a lot of homework, right? They're going to nail you. And it covers a lot of topics, and you're like, oh man, I can't do any of this. Like I can, this doesn't even look like the examples you worked in class, and these are much harder than the ones, like, oh no. And pretty soon you're getting confused. So what are your options at that point? You can't get a tutor right now. You can't go to office hours. You're working full time. Math lab's a pain in the butt, and that's like just more students teaching math lab. like helping the tutoring center or whatever. So there aren't any good options at that point, but that's what this site is all about. So on my website, I've got all these videos covering every little minute topic in all these college classes. So when you're sitting there doing your homework and you're not sure how to do it, well, guess what? You just find the video covering that topic on the site, and I explain everything to you from the easy problems to the hard ones, just like I would if I was sitting at the table with you, explaining how to do it. So you basically get a private tutoring session, but it's super cheap and super available. It's 24/7. So that's how you can get through the semester. So hopefully this is my third time talking about this, but hopefully I've convinced you to really prep well for the Accuplacer. At least do all these videos and the practice tests. And then hopefully I have a little bit more time. You can do even more depth. So that if you went through Algebra 2 in high school, it'd be good to take pre-calc as your first college course. You don't want to have to retake college algebra. But even then, after you've done well in the Accuplacer, or don't do well, maybe don't have time to prepare for it, so you do end up taking an extra semester. But once you've done that, use the videos on the site to get yourself through the course and doing well. You do not want to start a class and kind of like see if you can do it on your own and then start suffering. Remember, 75% of students that start a college math class do not get credit for it. So they either have to drop because things aren't going well, obviously. No one drops because like, oh, I have an A, but I'm going to drop and go again next semester. That doesn't happen, right? So people who drop are doing so because their grade is bad. And then other people like try and make it all the way to the end and then just don't get good enough grade in the final to bring it up to a passing grade. So if you have a D, you're not going to get credit, right? You can't transfer with a D on your resume. So you end up having to retake it. It's a bad scene. So you don't want to be one of the 75%. You want to realize that college is much harder than high school. You're going to have to pump through it and do well. So use the site to keep up with things. Way cheaper than a tutor. Way, way, way cheaper than having to retake a class. So stick around for more videos. I'll see you in the next one.